Today we're going to talk about a magnetically assisted linear solenoid. Now what we're going to do, we have a shaft here, a steel shaft, it's 2 1/4 inches long. We're going to put this up inside this solenoid, and as you can see it just falls through, does nothing. Then we're going to come up here and turn on the power supply, and as you can see it's running 24 volts, about 250 milliamps. So now we're going to come down here and we're going to put this shaft up through from the bottom, and you can see that it stays in there, but just barely stays in there. It wants to drop right out the bottom. Now we're going to add these powerful magnets to each end. There's one on this end up here. They're north pole facing in toward the shaft. Now the other magnet is down here. So I'm going to drop this in from the top, and as you can see it's already floating there. And now I'm going to put the other magnet on the bottom, which will make it even stronger. Now it's even stronger. And then over here we have a scale. I'm going to turn the scale on, and it's in ounces right now, and this is a weight. We're going to drop this weight on there, and it weighs 9.77 ounces. Now we're going to set this weight on top of here, and as you can see down in here it does support the weight. So basically the solenoid is holding 2 magnets. They weigh 4.86 ounces as a pair. The steel rod weighs 2.71 ounces and the weight is 9.77 for a total of 17.34 ounces, or almost 500 grams. Now originally when we started, this solenoid wouldn't even support the weight of the rod, but with the magnets it supports over a pound. And what we're going to use this for is I'm going to turn this into a gravity assisted solenoid motor in a future video, and I'll start posting pictures and videos of how to make the parts to build this thing. As you can see, we're still on up here, still 230 milliamps, 24 volts, and it's got quite a bit of thrust. So we're going to test it out and make it into a motor and see what happens. That's it for today.